Question 1b, please take down, please. Question 1b, given two charges Q1, equal to plus 6 microcoulomb, given two charges Q1 equal to plus 6 microcoulomb and Q2 equal to minus 6 microcoulomb. Separated by 12 cm along the x-axis. Separated by 12 cm along the x-axis. Separated by 12 cm along the x-axis. Full stop. Find the potentials at point A. Find the potentials at point A, comma. Find the potentials at point A, comma, 4 cm from Q1. Find the potentials at point capital A, comma, 4 cm from Q1, and at point B, comma, 16 cm from Q1, and at point B, comma, 16 cm from Q1. Full stop. Give explanations for your answer in the potential at point B. Give explanations for your answer in the potential at point B. So look up, please. So that's your test question last year. It also came out in your exam. So there's a likelihood that they might repeat the same question. Sciences does almost every time. So first things first, I said your first task is always to sketch out the diagram for this. So let me try to sketch diagram for this. So I have Q1 and Q2. So my first task, choose a point, any point at all. Call this Q1. So Q1 is equal to 6 microcoulomb. 6 microcoulomb. From here up to another point here. Let's call this Q2. So we said Q2 is equal to minus 6 microcoulomb. So I have these 2 points. They said distance of their separation is 12 cm. So let's say from here to perhaps here. Now see where I'm drawing this. I am giving a space here because I expect something in between. So I'm giving a space there. Come down a bit. From here to here is about 12 cm. So I have 12 cm distance of separation. Now the question here says, find the potentials, that's electric potential, at point A. Where is point A? They said point A is what there? 4 cm from Q1. So Q1 is my reference. From here, I have a point A. Let's say somewhere here, I'm calling this A, such that distance from A to Q1 is about 4 cm. From here to here is 4 cm. I have this. All right. So Q1 is 4 cm from point A. What's again there? At point B, 16 cm. If I have point B, 16 cm from point Q1, what do you think? From here to here is 12. They said 16 from Q1. That means I still have to go which way now? This way again. So now have from here to right here, call this B. So B, such that if from here, look up please. If from here to here is 16, distance from here to here will be how many? So from here to here has to be 4 cm. Because I know that from here to here is 12. Since it's 16 from here becomes 12 plus 4. That's 16 from Q1. So I have this as my diagram. Those of you have the electrical field, when you thought like this, that's the problem we always face in USC. They give you a question that is not even in your notes. You have to think it out. It's not in your note, but that's the question. Both exam last year and test last year, they brought the question twice. Anyways, now we know what to do here, right? They said find the potential at A and at point B. So let's start with point A. Let's start with at A. So at point A, what do you have there? So look up, please. Look up. I want to solve both of them simultaneously. So that means at point A, electric potential at point A. So therefore, electric potential at A, I'm calling this VA, is equal to electric potential between Q1 and A, that's V1, plus electric potential between this and this. Don't forget, since it's this one here, all of the forces will act on this. So it becomes this and this plus this and this. For now, ignore B. So it becomes V2. We know that V is equal to what there? KQ over what there? R. That means for V1 is equal to K is 1. And because what there? Q1 all over what there? R1 plus Q2 all over what there? R2. So impute values. If I impute values, let's see if I can manage. Can I manage here? I should you enter. My right will enter here. Let me just use the whole stop there. So V at A is equal to, listen, it's equal to V1. V1 becomes K. That's okay. Let's do a bit of mathematics. Please, will it be right for me to say this is equal to, look up, a bit of mathematics? Can I factor K out of this? So it becomes K into what there? Remove K from here. What do you have here? Q1 over what? R1 plus what there? Q2 over what there? Please, this is correct. Because K times Q1 gives you this. K times this gives you this. That means V at A is equal to K 9 times 10 to the power 9 into, so multiplied by Q1 over R1. Q1 is what there? Oh, sorry. They are using small q. Well, the same thing. So you can say this and small q. Let me use their own term. Small q. Yeah, same thing, please. Let me just use their own abbreviation. Q1, Q2. All right. So it becomes 6 micro. 6 times 10 to the power minus 6 all over. What's distance there, please? What's R1? No, cannot be 4. Cannot be 4. 4 cm. So R1 is equal to 4 cm. Distance between Q1 and this. Divide by 100. It becomes what there? So become this all over 0.04 plus Q2. That's what there? Minus 6 times 10 to the power what there? Minus 6 all over. What's R2? Distance from this at point A. Distance from Q2 to A. What's the distance? 8. So R2 is about 8 cm. Convert to meters. Divide by 100. 0.08 meters. That becomes 0.08. Please punch this one. Sorry, excuse me. That's equal to 9 times 10 to the power 9 into, please give me this ratio, please. What do you have there? Give me this ratio, please. What do you have there? Sorry? Times to the power what? Minus 4. So just give me decimal. Okay, don't worry. 1.5 times 10 to the power minus 4. Let me use square brackets. So this one is for the first one. Plus, give me this one, please. Minus 7.5 minus 5. Okay. Excuse me. This and this. So that means this is equal to 9 times 10 to the power 9 into, see if you can punch all of this. Of course, plus minus will be minus. But then don't worry. Give me punch all of this for me. What do you have? So this one in bracket plus open the bracket, punch this one, close the bracket. What's the final answer, please? 7.5 times minus 5. All right, multiply this to electric potential at A, VA is equal to multiply this to what do you have? 675,000. This units, please. Volts. So I'm having volts. I'm done with A. I still have to find for B. Say at point A and then at point B. So next up, let's now get at point B. So VA is equal to about 675,123 volts. That's VA. Let's get at point B. So at point B, basically the same thing. At point B, basically the same thing. So at point B is basically the same thing there, just a change. What's that? Yep, just a change in what the distance. So VB potential at point B is equal to V1. That's the electric potential due to at point B due to charge 1 plus V2. The electric potential at point B due to charge 2, the same thing, just changing distance. So we'll have that V1, okay, VB is equal to KQ1 over R1 plus KQ2. So it's just the same thing there. The difference is now the value of R1 and R2. If I'm considering B as my point here, question, what's R1? What's the distance from Q1 to B? What's the distance? 16. So it becomes 16 cm. They convert to what? To meters. Divide by 100. I have what there? 0.16 meters. That's all. R2, distance from Q2 to point B. How many there? So I'm having 4 cm. Convert to meters. Divide by 100. 0.04. So the same formula and everything. All right. So it becomes so VB now is equal to K. That's the same thing there. Q1, same thing there, all over R1. R1 is now 0.16. So take this one off. Please, I want to clean this. Please, are you still here? Anybody here? All right. So R1 now 0.16. R2 0.04. So just the same thing there. The same formula and everything, just changing distance. That is equal to 9 times 10 to the power 9. Please give me this value. What do you have? This one here, 3 point minus 5. Okay, plus, give me this one here. 1.5 times 10 to the power what? Minus 1.5, excuse me, this and this gives you minus 1.5 times 10 to the power minus 4. So I have this. All right, so that's equal to 9 times 10 to the power 9 into, possibly give me all of this, please. What do you have? Minus 1 point. Hold on. That gives you minus 1 point, times minus 4. Okay, help me multiply this, please. That's VB minus 1.01 times the power 6 in what there? This volt. So I'm having this. So that's your answer, please. All right. The last question you should give what there? Explanation for the potential in B. So what do you say? What do you say? What do you say? So it's negative. So what happens? Why is it negative? So listen. What do you explain to them? Here's what to tell them. Please look up. If you that's why I kept A pending. If you consider between A and B, A is positive, B is negative. What does it tell you? It means that at point B, the electric potential has reduced, obviously, from positive to negative. Why? Because of what? Distance. I'll tell you what to write. Just listen. Now, here's how it works. Um, so what you say is this. You now say at point B, the electric potential or the net electric potential becomes, or you say, fine, how do I put this? At point B, the net electric potential reduces. Why? Because the distance has done what there? Increased. Now let me show something. Let me show something, please. Remember that our formula was V is equal to KQ over R. The relationship between V and R is what there? Inverse proportionality. And for inverse, as R increases, what happens to V? It will decrease. So hence, you say at point B, the electric potential reduces because the distance has been what there? Increased. You now say this is because electric potential has an inverse proportionality with distance. So take down. At point B, the electric potential reduces. At point B, the electric potential reduces due to an increase in distance. At point B, you can see here, the electric potential reduces this due to an increase in what? Distance. Full stop. This is because electric potential has inverse proportionality with distance. This is because electric potential has inverse proportionality with distance. With distance. With distance, you can see here, inverse. With distance. Hence, as distance increases, electric potential decreases as seen in B above. Hence, as distance increases, electric potential decreases or reduces as seen in B above. That's it. Question 1A from 2022 says, what is electric potential? So what's that? It is what there? The work done. Abi? In moving what there? Now hold on. When you're defining that thing there, remember to put at a point. Electric potential at a point is simply what there? The work done in moving a unit positive test charge from what there? Infinity to what there? That point. That's your definition. Alright. That's like a question mark. It now continues. 1A continues. It says, differentiate it from electric potential energy. Differentiate it from electric potential energy. So what do you say? When it comes to differentiating things in science, your first idea is differentiate them using what their definitions. You can now put it, you can just put difference between electric potential and electric potential energy. You can try it like that. Difference between electric potential and electric potential energy. Number one, I'll use definition. Number one, electric potential is simply or at a point, is the work done in moving a unit positive test charge from infinity to that point. That's your first definition. Then, onto electric potential energy, that's U. It is the energy that a charge has It is the energy that a charge has by virtue of its position in an electric field. That's one difference. So number one, I said use definition. Number two, use SI unit. Use SI unit. Under electric potential, write that please. It is measured in volts. It is measured in volts. Under electric potential energy, write down. It is measured in what? Joules. It's measured in what? Joules. You can just add something there, please. Electric potential is measured in either volts or joules per coulomb. Can you add that one if you want to? Or joules per coulomb. Let me give you one last one, and then we'll move on, please. One last one. Under electric potential. One last one. Under electric potential. Take that, please. It is the work done. It is the work done in bringing a unit positive test charge from infinity to a point. That's the third one now. It is the work done in bringing a unit positive test charge from infinity to a point under electric potential energy. Take down. Under electric potential energy now. The first one was electric potential. Now, under electric potential energy, take down. It is the work done in assembling. It is the work done in assembling or separating charges against the electric field. In assembling or separating charges against the electrical field. So that's 1A done. Bracket 3 marks. That's 3 marks. Now listen. We are doing question 1 there. 1C, listen. Once it says, what is electrostatics? What's the answer? Electrostatics is what there? The study of what? Charges and what? Charge system at what? Rest. That's all. It now says, state the basic principles of electrostatic. What's the basic principle there? Like charges does what there? Repel, and what? Unlike charges attract. If you want to go further, you can now use law 2. What's law 2 there? The force of attraction, that's Coulomb's law, between what there? Two charges is what? Directly proportional to the product of the charges, and what there? Inversely proportional to what there? The square of the distance apart. So we've answered one full question from last year. I'll drop the orders on the WhatsApp group. So we'll have, I think we're good for today, please.